Hi everybody, my name is Camille Ouellet Dallaire and I am a local. I'm actually from McGill University. So this is my first NACIS meeting, and so please excuse me if I'm not going into the depth about cartography that is required, but I would be more than happy to talk about this. So I've been doing geography since my undergrad. I'm now in my PhD, in my last year of my PhD, so I have a lot of year behind me of making maps. But in the past years, I've been working in my master's and my PhD specifically about rivers. And when I saw this ad to talk about cartographic design at NACIS, I kind of thought, well, rivers are really complicated to map because they're extremely small. And if you look at them from a satellite imagery, often they don't show up because they're hidden by trees. So I thought I would come and talk a bit about my experience with mapping riverscapes. So I'm going to be talking a bit about my research that I've been doing in my PhD. So you'll see I do a lot of river classification, but I'm going to be focusing on a part of my PhD that is looking at ecosystem services. And so I'm going to present a map about this. So I hope you enjoy the ride. So one thing about rivers is that they're this really long linear feature that are meandering all over the place. But when you think about a river, what we actually want to represent when we're talking about one specific river reach or one specific river segment, if you want, it actually isn't necessarily what's happening directly in that reach. We might be talking about discharge, which is something that is accumulated upstream. We might be talking about the influence that it might have downstream because we're looking at dams, and the influence is actually not happening necessarily only at the reach, but can also influence what's happening downstream. And so when I was trying to frame this talk, I kind of thought about rivers as these units where there's multiple scales that are folded into one. And I think that I was thinking about this for a long time this weekend. And I was trying to think, are there any other spatial units that do this? And I didn't really come to a conclusion. So I think that rivers are actually really unique as that they have a very special spatial dynamic than other units. I know that in the ocean world, yes, there's a depth component, but it's not necessarily this idea of moving water. And so one thing that for those of you who are not necessarily familiar with the idea of rivers, well, river goes downstream, which means that it goes from high to low, which is very simple ideas. But it means that for each of these river reach, there is a growing watershed that is associated with it. So what you see here on this map is as the little red dot goes down and down and down, you have a different upstream area that is illuminated. So in this case, in purple. So you can imagine that if you are trying to analyze a river system and you're trying to understand what's happening upstream, all of these different river segment or river reach are actually representing a different watershed area, which means that not only do you have different river that may be of different size, but the associated upstream area is also very different. And they can range from very small at the very top of the watershed to very large at the end. And so it's very dynamic. And trying to map this can be complicated because you're kind of folding many things in the same linear unit. So if we think about it in terms of if we were looking at the landscape, so let's imagine that we all transport in the Alps and that we're curious about this particular river. So one of the first things that we would be interested, well, as hydrologists, I am, I guess, is the runoff. So runoff is basically the water that accumulates on land. It comes from the rain, and then it can be evapotranspirated, and then it kind of runs down. And basically after that, it accumulates in the river. So this is not a complicated thing, but when we start thinking about how to map this, this is where it becomes complex. So let's say that we're interested by the very middle of the river. So let's call this the river reach of interest. If I wanted to map this, the very first thing I would need to know is what is the runoff accumulation zone. So in this case, it would be coming from outside the picture. And then even though I'm interested in this very particular river reach, which is a given point in a river, the downstream area can be very far away. You can imagine that technically any river at some point will reach an ocean. So if you're in Mississippi, for example, if we're all the way up in Canada, you're going to make your way all down to these thousands of kilometers. And so when we're trying to map rivers, we need to be conscious of these very distinct scale of these different units. So just to give it to you in a flat angle, the runoff would be happening in the headwater, and the uses often happen in the lowland. So this is where my research in ecosystem services basically comes in. When we work with rivers, and specifically with ecosystem services, these services, which can be anything that we benefit from the environment, if we think about water, it specifically be looking at things like the provision of clean water, flood mitigation, flood protection or mitigation, could also be fisheries. And all these things are occurring at a given point. But the runoff and also the accumulation of the impact in the stream flow are located at different area. So although we're mapping this very one thing, it has these impact in various other regions. So like I mentioned earlier, I work on ecosystem services and river system. And one of the things we do in ecosystem services is trying to map the capacity, the supply, the capacity or supply. We can also call this, and the opposite would be the demand. So in river system, I'm working specifically at a Canadian scale, so I map 8 million of river segment when I work in my research. And what I'm interested in is really trying to understand what is the spatial relationship among the different user, among the different river reach. And you can imagine that since, if you remember that image of the watershed is growing and the point that is going down, you can imagine that if someone is using water at a given point of the river, it might have an impact to someone downstream, but it can also have an impact on what's happening upstream. And so it's a very spatially dynamic concept. For my project, I'm looking specifically at the water provision in Canada. So I'm looking at the provision of clean water, which you may think it's not completely related to ecosystem, and why are we calling this an ecosystem services? But the provision of clean water, and especially water at a given time, is extremely related to the actual landscape. And so, if we come back to this figure of the watershed, when I work on mapping capacity, demand, and pressure of ecosystem services, what I'm thinking about is that the capacity is actually represented by the runoff, so how much water is created on a river. The demand is actually coming out of these settlements, which are actually on the lowland, and can be overlapping at the same time. And the pressure, which is basically the impact of what happened when we're using this water, is accumulated in the stream. So today I'm going to present to you a couple maps. I'm going to focus on the demand and the pressure. So just to give you an idea, let's imagine that I'm interested in the demand for water that are coming from hydropower. You can imagine here, if you imagine that these are dams, you can see that the most important part of the watershed is the very tip, because that watershed is actually providing water for all three of the dams. And if you look at the pressure, which we see in the lower right corner, you can imagine that as the color becomes redder and redder and redder, there's more and more problem, because there's more and more accumulation of different pollutants or use. So I'm not going to go in more detail about my methodology to do this, but if you have questions at the end, please let me know. I'll be happy to talk more about this. And I'm working on ecosystem services or water provision for both municipality, agriculture, and hydropower. So this is one of the maps that I created for my PhD. On this map, what you see is the demand for 3 services, for 3 beneficiaries, namely the hydropower, agriculture, and municipal. So the way to read this map is that I use an RGB legend. So basically, each of my components were associated with either the red, the green, or the blue. And what you see in these watersheds is basically the brighter the color, the more use there is, or the more demand there is. And colors that are mixed represent basically the ratio between 2 different uses. So for example, if you look in Alberta or if you look in the prairies, we see very, very bright green. So that's a high demand for water with agriculture. If you look in northern Quebec, you see a lot of watersheds that have this really bright red. And for those of you that maybe are not Canadian, northern Quebec has a lot of hydropower, like a lot of dams. And so that's well represented here. But you also see some watersheds that are in purple shades, especially near the Great Lakes or near Ontario. And that represents a combination of uses both for municipal and for hydropower. So you might be thinking, oh wait, this isn't a river. What are you talking about? So you're right, this is not a river. But since I'm trying to represent these different spatial units, I'm actually have to make choices in what I think is the best unit for this. Because the demand is associated with how much water we want, that is quickly associated with the runoff that is on each pixel. And so that's why using a watershed to me is more intuitive. You can quickly, by seeing this picture, figure out that, okay, this is where water is coming from, and this is where there's the highest demand. So when we're talking about pressure, that's a bit different because pressure, I decided to look at it on a river reach level, and that's because basically pressure accumulates within the river reach. It accumulates in the river, and therefore there's a very limited connection with the land where we're gonna have pressure. So basically, the river is not gonna overflow necessarily and have an impact on the landscape. The pressure from the use of water is maintained in the river. So here you see the same legend, so using an RGB legend. So the brighter we have a color, the more pressure there are, and we have the mix of colors depending if it's hydropower, agriculture, or municipal water demand, water pressure. I wanted to bring your attention to specifically the Saskatchewan River. This is this river system over here that goes into the Hudson Bay. Oops. Basically, what we see in this river is that it starts, the start of the watershed is where we have this kind of green goo happening. That's a high demand for agriculture. And we know that in Canada, we have a lot of grain and a lot of agriculture happening there. But as you follow the river downstream, you see that the color changes. And it's because the impact, or the importance of the impact as we go downstream, is closer to an impact from hydropower. It basically means that this river, there's a lot of dam happening, and a lot of them are happening towards the mouth of the river. Another interesting thing when we're thinking about mapping rivers is that since they are flowing away, often what we see is that the impact and the pressure are not occurring necessarily where the pressure is done. So let's imagine we have a dam. Yes, there's going to be impact where the dam is, but there's going to be lasting impact throughout the river as we go along. So when we combine these two maps together, basically what I'm trying to get at, and I'm really interested in sustainability, is basically this idea of where there are hotspots of risk to the provision of clean water. What you see on this map is basically everything that is bright blue means that there's no problem. There's a low demand, a high capacity, and low pressure. And everywhere that is in bright red, it means that there's potentially a low capacity, a high pressure, and a high demand. And you can imagine that by mapping this on the river, it can be very effective for people to realize where are the river at risk in Canada. And by presenting this on the river network, it really helps understand where we have these different issues. So I thought I would give you a bit of how I've been working with my maps, because you can imagine that when we work with rivers, there's a lot of play that is just based on color and hierarchy. And so I just thought I would give a brief overview of how I've been dealing with this personally. So since I've been working with rivers, and in Canada there's 8 million rivers, which means that there's a lot of line, and all 8 million of them are on this map. Yet it doesn't feel necessarily too crowded. So one trick I've been using is to use both color and symbol hierarchy to give kind of like this impression of depth. So I try to reproduce this in this very ugly word drawing, but basically the way I work is that I choose a U, and when my smaller river, I try to make them a little brighter, and as I go bigger and bigger river size, I make them darker. So not only do I play with the line size, but I also play with the colors. Some of my work is taking place in the Greater Mekong region, which is what you see here, and I thought I would just give you an example of how I build these maps. In this context, we've been working with different specialists to classify river system for management, but specifically for both biodiversity and special habitat in the region. So it was really important to be able to see all these different rivers. And there's about 50 different 50 different colors on this map. The way I work with this is that I start by picking colors for the very, very small river. And you can see that on the right-hand side, you only see the small rivers. And as we go bigger and bigger, these rivers, they don't look quite as dark, and they're not overpowering, although we can still feel them in the image. And then we can go bigger by using brighter color and using just wider lines. And finally, what you see here is the final map. And I think that what is important when you're mapping rivers is that if it becomes too blurry and you have too many rivers at the same time, people can distinguish, and then it's not as intuitive that you're actually talking about a river. So by using both the color and the symbol hierarchy, you're really able to convey to your audience that what they need to look at is this flowing network of river. And it's a bit more intuitive than when we're just working with pixels. Thank you. So as you see, sometimes when I'm working with 8 million rivers, I need to find ways to quickly explain to people what is happening. And I realize that I've been working with maps with rivers for 8 years, so sometimes I see things that most people would not notice. But that's what happened when you work too long in these things. So lately, I've been experimenting with using infographics. So when I've been presenting these results to a broader audience, I've been using the maps to really give a sense of the size of the word, the scope of the word, but I've been using this infographic to really display exactly what is important or what I wanted them to take away. So what I've been working on is using just these 100 tokens of river, and then I've just been using a simple color code to present to people which province in Canada had the biggest potential issue with their river. So you might be surprised, but the Nunavut or the Northwest Territory are actually states that have really high risk on their river, on their water provision. And that's something that by just looking at the map is not as intuitive. So I found that by using these kind of topology, it really helps. Another thing that sorry, I'm like horrible with arrows. Oh, no, that was on purpose. It wasn't just the arrows. Sorry about that. So what I wanted to show is that, basically, there's similar information that is conveyed in this map than on this map, but it's often much more easy to grasp. And one of the other things that is really important is also this idea that having rivers of different size, it means that you don't see the small river very well. So by using this kind of infographic, it really helps to extract this information to make sure your audience know what you're talking about. So a few take-home messages. So mapping Riverscape, one of the things that I found difficult is handling multiple scale in one spatial unit, trying to represent both land and water, but also I've been trying to focus on this, trying to solve this problem by using both color and symbology to create the depth of the river network. So thank you for your attention, and here's my email and my Twitter handle if you wanted to reach out. Thank you.